All right, so last day of limits. We're doing limits involving infinity. So instead of going to like 1 or 2 or 3 or a normal number, we're gonna do limits going to infinity. We're gonna start off by graphing though. So here we have a graph and we have a list of limits, and we're gonna use these limits to sketch about what the graph will look like, or like the points of discontinuity of the graph, basically. So you're gonna start here. This says as x gets really small or x goes to negative infinity, we want the y to go to positive infinity. So sketch something that would look like. So something like this. It doesn't have to be perfect. It doesn't have to like be the exact right thing, but going in the right direction. And then you're gonna go to the next one. So at -4, so right here at -4, we want the limit to be negative infinity. This doesn't tell us from one side or the other, so we want both sides to go to negative infinity. So connect somehow to your other limit. It doesn't matter how you connect it. You could do like weird squiggles in between. You can draw a nice line, whatever you want to do to connect. So you're both going down to negative infinity. All right, next we're looking at 3. So right here at 3, from the left-hand side, we want to be at 1. So right here, we want to be at 1. So then connect somehow. Again, doesn't really matter how you connect. Next chunk, still at 3, but from the right, we want to be at 4. So here I have a filled in circle already. So at 4, I want a closed circle. So you have to have at least one open circle on your graph. You can only have one closed because otherwise you're not a function if you hit two things. So keep one circle open. And this is going off some way. So draw something. And then the last part, let's do it in pink. As we go to positive infinity, we want to be at -2. So we want like a horizontal asymptote right here. So this needs to come down and make an asymptote. Again, the stuff in between doesn't matter. So like this part and like this part and like this part, it doesn't really matter what you do. What matters is right at those points, what you're doing. Okay, these next ones we're going to do without a calculator. So thinking of x, what does that graph look like? It's going to be something like this. So if we're going as x approaches positive infinity, we're over on this end, your limit is going to be infinity because you just keep going up. If we then think of negative infinity, we're on the other end, we're down here. So we'll highlight, there we go. So we're at negative infinity. All right, here, back to our 12 basic functions, you should have a graph that looks something like this. So at positive infinity, we're over here, and negative infinity, we're over here. Both of those are going towards 0. The reason being, this is getting super, super big. So you have like 1 over infinity, or like 1 over 10 jillion, which is basically 0. The next one, if we sketch sine, we're going like this, right? So as we go off to positive infinity over here, sine is just going to keep oscillating. So you're never going to get one value. So this does not exist. Okay, so combinations. You have to think about what's happening here. So x is going to be going like this to positive infinity, right? Sine is going to be oscillating. So you're taking like infinity plus or minus 1, because sine can go up to positive 1, down to negative 1, and it's in that range. So you're taking like 5 jillion plus 1 and 5 jillion minus 1. It's still some really huge numbers. So your end graph is going to look something kind of like this, like you're going to keep going up, but you're jiggling back and forth. So you're going to end up with infinity as your limit. So the next one here, we're still going to infinity with x. Sine is still oscillating, but now we're multiplying. So we're going like positive 100, negative 100, positive 200, negative 200. So you're doing something like this. You're like starting out small, but then you end up getting bigger and bigger and bigger jumps, but you're still oscillating. So this doesn't exist. This last one here, sine is still going like this, or plus or minus 1. This is still infinity. So you're taking like 1 divided by 5 million, -1 divided by 5 million. So this one is going to like start out big and then end up going like this. So it's going to be 0 as your final answer. I'll highlight those so you can see them. All right, to think of these two, the graph of our exponential looks like this. So at infinity, we're up over here, which is going to be up at positive infinity. Negative infinity, we're down over here, which will give you 0. You can think of this, you're getting a negative exponent. So you're really getting like 2 to the negative infinity is the same as 1 over 2 to the infinity. So you're getting close to 0. So then combining these, this one is going to infinity, this one is oscillating. So the infinity is going to take over when we get infinity. Here this is going to 0, this is oscillating. So you get does not exist. Last chunk here. So these you can kind of think about horizontal asymptotes, like what's happening at the tails of your graph. So if we go back to our rules, when these were the same value, these will cancel out and you'll be left with your a over b. So you're going to get 3 as your limit. Same idea here, you'll get 3 as your limit. You're looking at just the first terms. So here, if we had like 3x squared over x plus 5, and x squared is going to grow a lot bigger if we go towards infinity. So this is going to get really big. If we had something similar, so say 3x over x squared plus 5, the x squared is going to grow bigger. So then the bottom is going to get bigger and you're going to go towards 0. Again, check on Schoology to see what your homework is, and that's it for notes.